in this lesson, we're going to work one more example with coterminal angles and then move into what's called reference angles. So I'm going to start out by labeling my coordinate plane here. So I can see that this is in radians because there's no degree symbol. I'm less familiar with these numbers, and so I'm going to calculate those. So this is 0, of course. This is pi over 2, so I can take the pi and divide by 2 and get 1.57. And so here I know is 180 degrees, or pi, so that's 3.14. And then down here, to calculate that, I can do 3 times pi and then divide by 2, and I get the 4.71 is the abbreviation, or is the what we usually take that value as. Okay, so then we're going to convert this. So we have to first of all think, oh, and let's do one more. 2 pi is 6.28. So when I look at this, I can see that this does fall into this range. In fact, I can see that it's going to be in the third quadrant because the value is between these two. So when I look at that, I know that my theta, so if I call this my theta value, it's going to be somewhere, let's just go with here. Okay, so now I need to find a positive one, so I'm going to say now I want to add 360 degrees or 2 pi to this, so I'm going to be adding my 6.28. Okay, and then this one is going to be my negative, so I'm going to take my angle value, that's equals, not negative, and this time I'm going to subtract, and I get negative 2.39. And that makes sense, so that would be here, because it's going to be less than the 3.14. And then I need a general one, so I'm going to take my original theta and add to it my 6.28, my decimal form, times k, which is any integer. Okay, so now let's move into what's called reference angles. Okay, so reference angles, for an angle theta in standard form, the reference angle is the positive acute angle. So acute, remember acute means that the angle is less than 90 degrees. So if my angle is theta, then it is less than 90 degrees. Okay, and it is formed by the terminal side of theta and the positive or negative x-axis. So what that's talking about is this. So I have my coordinate plane, and then I'm only dealing with the x-axis. Okay, so this is the positive side of the x-axis. This is the negative side. Okay, and you'll see what we're talking about. So in the following figure, the reference angle theta prime, the way you read that, for an angle with theta radians in standard form is shown. So this one is shown. Here's my theta, and I want theta prime to be the reference angle. So what I'm looking for, I'm only using my x-axis. So my theta prime is going to be here. Okay? And actually I'm measuring it up from the x-axis, so it should be going that direction. So I have 180, and I'm going to take away my original, which is basically pi minus theta. So So that's what happens when your angle falls in the second quadrant. Now when it falls in the first quadrant, it just equals itself, because again, we're just dealing with the x-axis. I'm measuring it here, and so it's its own reference angle. So in this case, theta equals theta prime. Now in the third quadrant, so when my angle falls down here, again, everything is in reference to that x-axis. So here, I'm going to have a reference angle that looks like that. Okay, so it's going to be my original angle minus 180. And that's going to give me that. Or if I was in radians, minus pi. And then if it's in the fourth quadrant, so this time I'm going here. So it has to be an acute angle. And it is a positive angle, so we're going to be measuring it actually in a positive direction. So it's going to be 360 minus theta, and then 2 pi minus theta. Okay, and I'm going to go back up here for just a second and clean that up, because it should be a positive acute angle with its terminal side creating that acute angle. So you're going to still read this as a positive angle. So for instance, if this angle, if my theta here was 120, then this reference angle would still be a 60.